Welcome to this free online course on machine learning offered by MT Learners. In this video, we will talk about logistic regression and after that, we will implement in our Jupyter notebook. So, logistic regression is a statistical model that is often used for classification and predictive analytics. Logistic regression estimates the probability of an event occurring, such as voted or didn't vote, based on some given dataset. Since the outcome is a probability the dependent variable, the outcome is bounded between 0 and 1. For example, to predict whether an email is spam or not, or whether the tumor is malignant or not. So, what logistic regression really does is it takes some input, some features, and based on that features, it gives its prediction in binary form. Like on the screen, you can see happy or sad. So always the outcome is in binary form, 0 and 1. So how logistic regression works? It works with sigmoid function. That function is a mathematical function that takes any real number and maps it to a probability between 1 and 0. Here you can see the formula of sigmoid that 1 over 1 plus exponential of minus z. So that was about Sigmoid function and logistic regression. And we'll go towards our Jupyter notebook and you will get to see how the Sigmoid function is implemented in code. And you can see a plot that uses the Sigmoid to improve the classification task. In this lab, we will explore Sigmoid function and implement in it. Before that, we will import some libraries like NumPy and Matplotlib. NumPy for scientific computing and Matplotlib for plotting the data. In the next cell, you can see we have input array of three participants, 1, 2, 3, and exponential array, in which we have converted our input array into exponential array. We call our sigmoid function that was 1 over 1 plus exponential of minus z. So that this cell is an example of converting an array into exponential array. So after running, we will run it. Now you can see that it has successfully converted into exponential array. So let's define our sigmoid function. That was def sigmoid and parameter is z. And what this function is going to do is that converting this z into sigmoid. So define a new variable sigmoid that is 1 over 1 plus exponential of this parameter z minus z. And return sigmoid. So now our function is good to go and we will define our z variable. Z is equal to np dot. So let's say our z is from minus 10 to 11. Range minus 10 to 11. For example, that our z variable has the variables from minus 10 to 11. So now define our y variable that is sigmoid of the z. Now if we print our y, so you can see that it has successfully converted this z into sigmoid and stored in y variable. So let's see this sigmoid and z variable in column. So print for z output y. Print we have z and y. So here on the left side we have input from minus 10 to minus 11. So that was our z array, and on the right side corresponding to them we have our output that is the sigmoid of this array. So we can also plot this data with the help of matplotlib library. So for that, x is equal to plt dot subplot fixed size is equal to, you can give any for default value. I'm giving 5 and 3 dot plot z and y. So set title. Our title is Sigmoid function. So set x label. On our x label we have z, and on our y label we have sigmoids. Dot show. So this is the sigmoid curve. You can see now from -10 to ranging to 10. So that was about sigmoid function. And now in the next lab, in the next class, we will see how we can implement logistic regression with the help of scikit-learn library.